Hello, and welcome to AcceliGOV. My name is Michael Lake, President, CEO, and founder of Leading Cities. We are a nonprofit organization headquartered in Boston, Massachusetts, but we work with communities, municipalities all over the world. And in that work, we identified some years ago that there was a real gap between innovators and the creations that they've come up with, the solutions to urban challenges, and the municipalities and the governments that need to be deploying those solutions. To bridge that gap, we created a program called AcceliCity. It has become the world's largest GovTech-focused accelerator program. Just to give you a sense, last year alone, we vetted over 650 solutions from 80 countries. Of those solutions, we are now offering 6 pilots of some of the top innovations that we found from around the world. You will now have an opportunity to hear from those solution providers. Get a sense of not only the solution they've created, but the pilot they're now offering you as part of our AcceliGOV program. AcceliGOV exists to connect these opportunities to pilot innovative solutions in your community. If you have any questions regarding the AcceliGOV process or the pilots or even the solution itself, please do not hesitate to reach out to us at AcceliGOV@leadingcities.org. That's AcceliGOV @leadingcities.org. But now, and more importantly, I want you to hear from this solution provider to inspire you as to why you should be applying before our February 29th deadline for their solution. Thank you very much for your time and attention, and I look forward to hearing from you with any further questions you might have.
Hello, everybody. I'm going to give a quick briefing of the exciting AcceliGOV opportunity with our Infido box. I'm Kathy Meaney. I have Neil Pantelich, one of the other directors, with us. We would love to answer questions. So the idea of this is hopefully just to enthuse you, excite you, and invite you to follow up with any further queries you might have ahead of the submission for the program. So a little bit about us first. We're an Australian company. We now have entities in Europe and in New Zealand, and we're basically privately held, and we've been working on nature-based solutions, particularly in the water space and biodiversity space for over 21 years. So we're not new on kids off the block, but the Infido box is probably the culmination of a lot of our green tech nature-based solutions packaged into a compact type of technology. We do both services and products, and for us it's important that we work with our clients to really optimize and tailor what we're offering them and to understand your problems where you are locally so that we provide the best fit in terms of solving problems and sharing things that can be scaled beyond the individual first project that we might get involved with. So a lot, as we said, water treatment, blue-green infrastructure, or nature-based solutions as they are for climate, livability, ecological restoration. So everything from pollution control to rebuilding biodiversity, and then accounting for that, valuing it and building economic opportunities off the back of that is the thing that we're really interested in. In terms of the product space, the Infido box is one. We have others, but again, we provide the end-to-end design, fabricate, install, operate services, and we offer a lease models, purchase to lease, training to become service providers so that people can get involved in their own solutions. So the Infido box is, I guess it's we call it a smart nature-based technology because it basically combines the IoT, so basically advanced controls for remote monitoring and operation anywhere in the world, with the very passive nature-based ways of treating water. That way we can target all the sustainability and circular economy SDGs, such as the net zero, no zero waste, and full reuse and repurposing of the asset at end of life. We're also very much a company that has as much an architectural and artistic focus. So It's about creating ways of people to interact with water and water treatment so that the focus is on the value of that water resource rather than on a treatment process, which is not so sexy and doesn't really help any of us get very far with the water crisis. And you can see there we're here largely because of the program, the AcceliCity program, that's really helped us to move this product forward. So I guess in terms of the solution itself, it's a local decentralized solution. So it's basically taking the water that you might have. So that might be contaminated groundwater, it might be stormwater, it might be municipal wastewater, and using that water, treating that water so it can be reused for whatever you might need that for. And that could be anything from micro farms, if you're in an urban space, that then can create an economic output, could be for offsetting irrigation needs during drought periods to get you through your vineyard production or a crop. Could be for treating things like dairy wastewater that currently creates a pollution endpoint so that you can return it to the cycle. So it's a very flexible technology, and the box is designed so that we can adjust the components so that we can meet the treatment needs suited to the wastewater type. And you can see here it's also, apart from the water, it creates biomass. So you can see there's plants, there's biosorbents, so natural products that then can go back into, again, compost, soil improvers, stock feeds, and various other uses. And it's obviously a decarbonisation technology. So each of the boxes roughly can treat up to 100 kilolitres per day, which obviously depends a bit on what you're putting through it. But if it's not super toxic, that's roughly what you would expect. It's very space efficient. So the box, in terms of the removal rates per square metre, are far higher than if you were doing a wetland or other technologies. So it's very good if you've got space constraints for treatment, which of course is all of us these days in urbanised world. And it has a really big range of capacity in terms of what it can treat. So nutrients, organics, metals, hydrocarbons, pathogens, pesticides, etc. And we're particularly interested in this pilot trial in testing it for its full capacity, as many things as we can throw at it. Yeah, and of course, there's mixed streams and emerging contaminants such as microplastics and hormones and all those modern day things that we use. And then it's scalable, it's very modular, so you basically can bank them together so you can increase the capacity at any particular site and its treatment efficiency, etc. But you can also use it with other technologies. So if you're already a big municipal wastewater treatment plant, it can go to the back end of that. If you've got RO, but you need something to remove your organics at the front end, etc. It's very much a friendly technology that works with other technologies. This is actually a picture of our prototype at the minute in Europe, which is a bit further along than that now, but nearly ready for deployment. That would be our pilot system. It's basically natural process, local products. As we said, the whole thing's renewable power, so it's very low energy, and all of that is offset by renewable, which we either can provide for you, we can provide a battery for you if you've already got renewable energy. No waste streams, so that means low energy, zero waste, and because there's no waste and with very little energy, the operating costs are much lower than other mechanical package type technologies. So I guess inside the box, the media is all natural, so plants, biosorbents. We use a lot of the modern enhanced biochars. We use all sorts of plant-based biosorbents and plants to do the trick, and a lot of it's, of course, the microbes attached to all of those that actually do the work. And then we use either floating aquatics or emergent aquatics, and they're automatically harvested to help remove contaminants progressively, and literally all of that's remotely operated and controlled. This is a little picture of the harvester. on the unit that we've got in Europe at the minute. So that effectively is just set so that it automatically harvests those plants into a bin for reuse of the material whenever somebody's on site to do it. You can see it's basically, it's not a sea container, it's a very robust bespoke custom steel container, but it's ISO certified and therefore it can be transported equivalently, but it has a lifespan of 100 years or so, and that's so we can, again, you might use it somewhere and then in a year or two's time you might wish to move it somewhere else, so it's designed so it can be endlessly moved to suit without it, like a sea container, suffering from structural issues. And then I guess one of the other interesting parts of this is the IoT. So while it's this, you might have this somewhere that you may be nervous about. The IoT capability gives you complete real-time insight and control to the system wherever you may be. So that can be used for operational control changes if you wish, changing flows in. And it has a full water quality and telemetry system, so you can check that the water quality complies with what you need. So this is one of the big changes, I think, in this technology compared to others, is that kind of decentralized treatment, but very much centralized control. That really is a good way of managing risks for these types of technologies, which is probably in a little more detail. What can you do with it? Well, you can pretty well control everything from recirculation, you can backflush, you can activate aeration, you can harvest the biomass, you can change your intake rates, you can discharge to reuse or some other use if need be. So it's a fully secured control room. So again, it's vandal proof. There's alarms, controls, cameras, etc. to help really with that remote operation. In terms of the use cases, it's pretty wide and varied. So again, in urban settings, it might be better improving the water quality. I don't know what it's like where any of you live, but at the minute we're in a very, very hot summer in Perth, so all the urban lakes are suffering from algal blooms, cyanobacteria blooms, and people can't access the water for irrigation. So it has a great deployment capability for dealing with those sorts of issues of heat and drought and water quality bodies that are just no longer able to deal with these changing climate. Can deal with stormwater, and the US, for one, has big targets around stormwater reuse and stormwater quality guidelines, groundwater, etc. In remote sites, often it's municipal or wastewater supplies that are available. Sometimes the groundwater's been overused and it's local contaminants. Sometimes it's just local geology, so it's you might have elevated arsenic or something just because of the local rock materials. So again, it's just looking at what have you got, where might it be? It might be in mining, tailings or a water storage that's just not fit for purpose at the minute. Agriculture, resorts, hotels, industrial landfill. So our first prototype, in fact, was tested at an active landfill site on some pretty awful water. So just to fuel the imagination, this is a test case we've worked through to an economic outcome. So it's again using the infighter box, so one box to deal with, say, stormwater, to then basically service a 10-hectare urban micro farm in terms of irrigation for food production, which is quite a productive and economically viable proposition. So if you don't have the certainty of the water, or the water costs of using potable is too much, that's a good use. Another one we were looking at, for instance, in south of France, but also in Australia now, our wine regions are suffering from drought. So the boxes can be banked together in clusters and used then to overcome some of that drought period irrigation demand to maintain productivity and supply chains of grapes for wines rather than closing shop and having to move vineyards or to just not have a year where anything's produced. So really that kind of emergency irrigation, supplementary irrigation supply. And this one, again, particularly at the minute in the UK, the environmental discharge criteria are huge, and also in Europe. And there's a lot of targets in a very short time horizon for improving the treatment quality of water at the back end of municipal wastewater treatment plants and industrial treatment systems before they're released to the environment. So really massive expectations in terms of the quality of that discharge water. So again, our boxes in clusters can then be used to improve the discharge to the environment and to improve then that use in terms of its ecological contribution to maintaining wetlands and stream quality. So our offer, so that's kind of all the different things you can think about what to do with it. What we'll provide is basically the unit. So we'll bring out or freight and install the unit on your preferred site. We're asking you to basically give us a flat area, which just flat leveled. It doesn't have to be concrete. We're looking for a partnership with you so that we can work together to understand how to really maximize the not just it's treating water, but what else, the imagination, I suppose, around how it could be scaled in your own urban communities and beyond. We'll offer you the full IoT package so you can get to interact with the system and see how it works. We'll operate and monitor it, and we'll also give you insight into that. Some training, global promotion, obviously through the whole AcceliGOV program as well as our own networks. Training, so if you've got local people who, of course, it's a new technology, so just building that familiarity with how this might work in your municipality, in your community. And then a whole host of sustainability and ESG benefits. So this is a way of understanding how you can, I guess, report against these things that we all have to do these days to show our corporate stewardship. So I guess these are just some of the benefits we've talked to, mostly water quality improvement, obviously, but emergency preparedness is another. So a lot of people are interested in deploying these ahead of the obvious, not so unpredictable things that we now get, floods or droughts, so that they're basically ready to do the job in different circumstances. We provide through the IoT an API so you can connect to your smart city platforms if you've already got these things set up. So we don't ask you to do something different or new. And then, as we mentioned, there's a range of economic opportunities that we can explore, not just for the pilot trial, but moving forward. And obviously, it's a huge opportunity to educate everybody about the value of water and opportunities for decentralized treatment. So, as I said, really just a level site, what you want to use the water for, what type of water you're looking to treat, and then your in-kind time just to support the logistics, training, and so on, and any permits that you believe is needed depending on that application. So that's really it. There's obviously a lot of detailed questions you might have, and we're more than happy and very interested to hear from you if you wish to follow up with further questions by email, or if you want a more of a detailed briefing session, we're very open to that as well. So we'll leave it to you to follow through and follow up if you're interested, and really encourage you to put your applications in. We can always nut out and iron out details after the applications are in. Thanks very much.
Thank you.